do more review. This time we're going to do cardiovascular system. We're going to do respiratory system, not on this lecture. And then we're going to talk about acute and chronic responses. All right, so we're going to start off with cardiovascular system. So we've got 6 things that we're going to go through. And by 6, I mean 5. So just quick review, and I'm going to go through these pretty quickly. As always, if you need help or want links to old videos, please let me know and I'll get them back to you if you can't find them. So cardiac output's just how much blood is coming out of the heart every minute. Oftentimes it's abbreviated QC. Q is for flow, C is for cardiac. Okay, and we can calculate cardiac output by going heart rate times stroke volume. Even though stroke volume is usually in milliliters, we generally express cardiac output as liters of blood per minute. So if we take the end diastolic volume and we subtract the end systolic volume, in this case we get a stroke volume of 100 mils. If heart rate is 70 beats per minute, then cardiac output will equal 7,000 milliliters or 7 liters per minute. So what is the relationship between heart rate and stroke volume on cardiac output? Well, if we increase heart rate, that's going to increase cardiac output. If we increase stroke volume, that will increase cardiac output. Oftentimes what happens is one variable will increase while the other decreases in an effort to maintain cardiac output. That's assuming we're at like homeostasis or something. If we begin to exercise, both of them will increase. But there will be times, and we'll talk about this later, where maybe something happens to cause stroke volume to decrease. Well, heart rate will increase to try and offset that change. Now, another thing that can affect flow or cardiac output is pressure and resistance. So flow equals the pressure gradient divided by resistance. Okay, so let's talk about each of these things. First of all, we've got systolic and diastolic blood pressure. Systolic blood pressure is what's happening when the heart is contracting. It's that maximum pressure. It's occurring due to the contraction of the left ventricle. Just think about a balloon. As you fill up a balloon, that's like systolic blood pressure. Okay, you're filling that up. Think of the balloon as an artery. Okay, that balloon's expanding. There's pressure. That's because of the force of the air coming into the balloon. Diastolic pressure, on the other hand, this is what happens if you let go of the balloon. There's still pressure inside that vessel, inside that balloon, but it has nothing to do with the heart anymore. This pressure occurs due to that recoil. So if you let go of a balloon, the balloon itself contracts, creates a pressure, and that helps move air. Or if we're talking about our arteries, it helps maintain or move blood flow. Okay, so diastolic occurs during relaxation of the left ventricle, but that relaxation has no effect, is not causing the pressure. The pressure is due to the elastic recoil. This question will be on exam 1. We've got our baroreceptor reflex, which I talked about, I think on the last lecture when we were talking about hormonal control. So I'm just going to just kind of skip this, but this is important. If we've got low blood pressure, that's going to cause an increase in sympathetic activity and the release of epi and norepi. It's going to cause an increase in heart rate, stroke volume, and resistance, which will increase pressure. We've also got 2 pumps that we want to remember. Again, we'll talk about these later on in the semester, but I want to reintroduce them. So we've got the skeletal muscle pump. This helps get blood back to the heart. So when we contract a muscle, that's like our hand, we'll say our hand is the muscle, and we're squeezing a go-gurt. So the go-gurt's like a blood vessel. So when we squeeze the middle of a go-gurt, that causes the yogurt or the go-gurt in it to go up. Muscle contracts, squeezes a blood vessel, causes blood to go up towards the heart. Now, unlike the go-gurt that will fall to the ground and make a mess, valves open to let the blood through, but then they close to prevent backflow. So as we're exercising, we need increased blood flow to the heart, and the act of exercising causes more muscle contraction and helps get that blood back to the heart. Then we've got the respiratory pump. We contract the diaphragm. This causes the volume of the thoracic cavity to increase, which decreases pressure, and so we have a pressure gradient. So now it's easier for blood to go from the abdominal cavity to the thoracic cavity. Okay, so we fill up the right side of our heart and our lungs. What ultimately ends up happening is we actually decrease the amount of blood that leaves the left side of the heart. There is still blood leaving, but not as much. Okay? And so we have greater blood volume in our lungs at that time, but we have a lower stroke volume. This sounds bad, but it's not that big of a deal. because during exhalation, the opposite happens. The diaphragm relaxes, the thoracic volume decreases, which increases pressure. And so now that pressure gradient reverses. And what that means is we're squeezing blood out of the right side of the heart and the lungs into the left side of the heart, where it can then be ejected into the rest of the body. So we have lower pulmonary blood volume. And during exhalation, our stroke volume goes up compared to inhalation. All right. And over the course of time, the amount that leaves the right side of the heart and the amount that leaves the left side of the heart are balanced out, which is important too. Finally, we've got Wiggers. Now, I am not going to go through Wiggers here. That's up to you, but we will talk about it. And the concepts that are shown in Wiggers are very important. Now, remember, with Wiggers, it has several variables on it. Okay, and if you understand Wiggers, you can really explain what's going on with the heart. So our variables are the ECG, left ventricular, left atrial, and aortic pressure. The heart sounds, remember those are the closing of valves, and the volume of blood in the left ventricle. Okay, so remember, heart sounds are the opening and closing of, are the closing of valves, and so those change. Those will close or open when pressure gradients are different, meaning the relationship between ventricular and atrial pressure, or the relationship between ventricular and aortic pressure, depending on the valve. And we'll talk about this in class. The EKG tells us what's going on with the heart. Is the atria contracting? Is it relaxing? Is the ventricle contracting, or is the ventricle relaxing? Okay, and if you can tie these variables together, you'll understand what's going on during the cardiac cycle, and cardiovascular physiology is a lot easier to understand. And so with that, we will end.